Okay, that moved. Okay, so I'm just recording this on my phone, so I apologize for the distance. So this is a video of the worksheet as the world turns. And, so the first question says, rank the points A to D on which has the greatest speed. Explain your ranking. So we know that speed is the scalar quantity of the change in position over the change in time. And we know that speed is directly proportional to your position. So as your position increases, your speed increases. Now, with that being said, we can also see here that A is the farthest from the pivot point and D is the closest. So, with that being said, we would then know that D would have the slowest speed because it's the slowest distance. So it would be A has the greatest, B, C, and then D, so the slowest. And then for number 2, it says if the bar goes around once, how far would D go compared to A? So if we assume that the space between D and the pivot, C, D, B, C, and A and B were all the same, so that white space right there, if it was all the same, then we can argue that A will go 4 times farther than D, because again, it's farther along, so the circumference would be bigger. And then 3 says, what is the difficulty in using D, V, and A to describe the motion? So each position on the bar has a different displacement and a different velocity and a different acceleration. So you can't really explain the motion of the bar if every single point on the bar is not the same. There are no 2 points on the bar that will be exactly the same to one another. So number 4 says, can you think of alternatives to describe the motion? If so, describe below. So it would be to, instead of using position, we would have to then use the angle of the bar in comparison to its original angle. So let's say this is the original angle. When it moves, the difference in that, the change in the angle over the change in time would then give you an angular velocity, and that can be a way that we can describe the motion of the bar.